All right, as far as the gray, I can't do anything about the gray so much as the projector is a little bright. As long as you can read the black, the green, and this over here in the console, we should be okay. Can you read that part? A little bigger? No problem. That's fine. This is why we do this. Let's make that 30. Oh, whoa. How's that?
Yeah, or like the same size.
Okay, I think that's the same size. I'm not. I'm pretty sure it's the same size. If it's too small, please let me know. You can also follow along on your computer as well. I hope you are following along. So, line 23 will do the most basic thing in the world and will display for us this UFO data. Now, does someone remember / want to remind me in the class, what type of data does pandas create when we pull in a CSV? What is the type of object called? Data frame. And a data frame is a bunch of rows and columns, just like an Excel spreadsheet. It's a literal frame of data. Frames are rectangles. This is a rectangle of data. So specifically in the UFO data set, at the bottom of the data frame, it will tell us there are 80,543 rows and 5 columns. Now, those columns, which we talked about briefly last time, are the city in which the reporting was created, the colors that were reported, the shape that was reported, the state that the city is in, and finally the exact time, exact quote unquote to the nearest hour, the time that the report came in. And all of the times are in actually West Coast time because the reporting center is in Seattle, Washington. So all these times are actually reported in the West Coast Pacific time. So what is UFO.head5 going to tell me? The top 5, well, top 5, yes, but really just the first 5. This is really the first 5 data rows. Make this a little bit bigger. This is really just the first 5. And they're ordered right now, they're actually ordered by day. The time is what's in order in the beginning. Why? Is because that's how the data set was created. That's not Panda's doing, that's not my doing. When I scraped the data from the web, I took it in order of time, so that's how it was created. If you notice, the earliest time that we have for UFO reporting is in 1930. So these UFO reportings go back a very long time. Someone report. So, what is tail going to tell us? The last 5. Like head will tell us the first 5, tails tells us the last 5. And you'll notice that I'm moving around my panes just because I want you to get a better sense of the data all in 5 rows. What happens in Spider as you kind of condense this pane is that it will try to wrap around as pretty as possible. The problem is data usually has more than 5 columns. So even if you're in Excel, in Spider, in R, and whatever environment you're in, sometimes displaying 10, 20 columns can be difficult if you have a fairly small screen. So I will be moving the pane around just to kind of give you a better sense of what we're looking at. And a lot of the parts of pandas is, remember, filtering and sorting and kind of narrowing down. So more often than not, we won't be looking at all 5 columns. We'll be looking at specific columns that we want to actually analyze. So does anyone remember what describe will tell me? The mean, the median, the basic descriptive statistics for which columns? Well, yes, for numerical columns, but if you notice about the actual UFO data set, which columns were numeric? Technically, to pandas, numeric would mean int or float. So even the time isn't numeric. So, in the UFO data set specifically, when I do .describe, it will tell me the categorical descriptors for each column. So for city, I have the unique count. The top is Seattle. Surprise, the Seattle, Washington is where the reporting center is. And how frequent it is. And the colors reported, the most common color is orange. The most common shape reported is light. The most common state, however, is California. There you go. And the most common time was apparently July 4th, 2014 at 10 p.m. was apparently the most reported time. 45 people. 45, can you guys read this behind the board? I like this thing. 45 people reported a UFO at around 10 p.m. on July 4th, 2014. And we'll explore that a little bit deeper, that exact day. We will be exploring July 4th because it's a very interesting day in terms of UFO reportings, as we'll see. Last time someone mentioned the index. They hinted at it. Well, in pandas, every single data frame has an index. Just like a list has an index, 0, 1, 2, 3, 4, 5, we count by the zeros. By default, the index of a data frame is also 0, 1, 2, 3, 4, 5, numeric. Now we can change the index. The index is just a way to uniquely identify a row. And the easiest way to uniquely identify a row is just to count upwards from 0. This is the 0, this is the 1, this is the 2, this is the 3. However, there are times where we can change the index to be something else that is unique. Many times when people are working with time data, things that change over time, they choose time to be their index. Because usually, in their case, you don't want to have 2 reportings in one specific time. Here that wouldn't work, obviously. We have 45 people reporting at 10 p.m. on July 4th. So time can't be the index because it's not unique. So we'll keep our index to be numerical, 0 counting up. UFO.columns will tell us the column names, city, colors reported, shape reported, state, and time. If you recall, the data type is object. If it's a string, there's no string type in pandas. It's called an object. And who remembers what the shape will give us? A tuple of what? Rows and columns. Exactly. Where the first element is the number of rows, 80,543, and the second item is the number of columns, which is 5. So shape is just a very quick way to tell us the shape of our data frame. So all of this is the exact same as we've seen on Monday, but this is a new data set. So as we move along, as we said before, the type of UFO is called a data frame. And we mentioned before why it looks so redundant, because the person who created pandas, inside of pandas created core objects. Inside of the core objects they made a frame. The most basic type of frame was a data frame. So it sounds redundant, but really it's just more of a hierarchical structure of objects. Really the way in canonical terms, however canonical you have conversations with over lunch, we call it the data frame, not the pandas.core.frame.data. The data frame is the basic object of pandas. Now, we can call a column in 2 different ways. We can use the dictionary notation, using the square brackets and the name of the column, UFO state, and that will give us the entire column of state. Now, does anyone remember what type a column is? So, series, exactly. Every column is a series. So a data frame is really just a bunch of series. You can think of a data frame as a literal dictionary where the dictionary's values are called series. So we can call the column by its equivalent nature using the dot state. Does anyone remember what the downside of using the dot notation? If there's a space in the column name, you can't use the dot notation. So more often than not, I will use the dictionary definition or notation because it will always work. But you will see people using the dot notation, so it is good to see. Case here, shape reported is 2 words, so we must use the dictionary notation to get the shape reported. And as we said, the type of each column is called a series. So there's series and there's data frames. Those are the 2 basic types of objects in pandas. So far, nothing new. Now we can call describe on a single column, like state, like we can call it on the entire data frame. So if you describe state, which is categorical, not numerical, it will tell us the number of items in state, 80,543. How many unique ones are there? 52. The top most occurring is CA, California. And how often does California occur? 10,743 times. Is someone scratching their head right now? That's the 52 states? I wonder why that is. Anyone want to take a guess? Why do you think there's 52 states? Maybe Puerto Rico. That's Very legitimate and maybe belong in another territory. What else? Any other suggestions?
Washington, D.C.
Hold on. DC? No one. Yeah, DC is not a state technically.
There's error in data.
What kind of error do you think could happen?
Maybe typo.
Someone typed in the 2 state code wrong. Well, let's actually take a look at the value counts. What is the value counts going to tell us? How many occurrences there are for each unique, whatever I tell it, state. If you look at the bottom, you will see FL and CA not capitalized. Pandas is case sensitive. So uppercase C and lowercase a is not the same thing as uppercase C, uppercase a. So Florida, so really the 52 is just an anomaly. There's 4 Florida accounts and 1 California account that's not getting counted. Which actually begs the question, where is DC? I guess, I don't know where DC, how that's getting reported, if they are reporting it at all. Maybe they're all just too busy doing nothing. See, it's funny because I'm from the area, so it's okay. Okay, so UFO shape 0 will give us the number of rows, 80,543. Recall, UFO.shape is a tuple where the first element is rows, second element is columns. So when I take the first element of that tuple, it's just the number of rows. Why do I want that? Well, here's an interesting way of manipulation. I can take the value counts of state and divide it by the number of rows. And what would that tell me? The percentage. This will exactly tell me the percentage of UFO sightings per state. So, California occurred 10,743 times, I believe. But as a percentage over all of the sightings, it's 13.33%. So this is a very simple way of taking the value counts and just dividing by the number of rows to give you a very basic percentage. So now we can see percentages. So the second most occurring state, Washington, is only at a 5.9 or about 6% of all reportings are out of Washington. 13.3 are out of California. Again, about 6 are out of Florida, so on and so forth. As you get down here, whereas good old Maryland only has 1.3, and keep going down. North Dakota, they got apparently plenty of other stuff to do than to report UFOs in North Dakota, because they got none, pretty much. Slicing, filtering, and sorting. So as a sanity check, we've been doing a lot of stuff, like mathematically speaking, but UFO has remained completely unchanged. We've done nothing to change the actual data set. Even when we do value counts, even when we do selections and types and describes and infos and shapes, even as we do all of these methods, the actual data frame remains pure. Nothing changes unless we explicitly tell it to change. Which is a very nice thing about pandas that you want to know. Nothing's going to change unless you tell it to. If we need to add a column, remove a column, change a column, delete rows. None of that's going to happen without our consent. So, recall from Monday, we can select multiple columns. And remember the double bracket notation? Does anyone remind me or remind class? What is the double bracket notation? Why is there double brackets? So if I say UFO, bracket, 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 what does the outer brackets represent? It's the dictionary selection, right? This is the selection. Now what do the inner brackets represent? List. So this is us literally passing a Python list into the selection operator. So here, we'll only take the columns state, city, and shape reported. Notice at the bottom, 80,543 rows and 3 columns. The 3 columns being state, city, and shape reported. Again, just like last time, I will make a list called state and city. Throw that into UFO, and it does the same thing. It will only select state and city. So this is me separating out, creating a list, and putting the list into the selection operator. Question. What type is UFO mycogs? I hear data frame. Anyone have any other? Is it a series? Is it a list? Is it a dictionary? It's a data frame. When you select multiple columns, you are inherently choosing a data frame. If you are selecting one column, it is a series. Series are one-dimensional. Frames are two-dimensional. I have some notes here, just about some notation that I've been explaining, but I've explained it already, so I'm going to go ahead and move past to logical filtering. So I've added some new types of logical filtering from Monday, so this is not all review anymore. Line 80 will select what for me? I'll say it again, a little bit louder. Everything reported from Texas. Which columns?
All columns.
All of them. Exactly. So this is, again, 5 columns, but now the number of rows has changed. Why? Because every single observation here on the screen, its state is Texas. Again, I can make this a little bit wider, and we can see every single item is coming from Texas. City doesn't matter. I just wanted where the state was Texas. Fair enough? Here's a new notation. This tilde in line 82 means not. So line 82 is the complete opposite. Line 82 is choose everything where the state is not Texas. So you'll notice there are a lot more rows, 76,357. This is every single row where the state is not Texas. And in fact, you might be saying, well, I feel like I could have done that in another way. And you're absolutely right. Because lines 83 and line 84 are exactly 2 other ways of doing the exact same thing. So as you'll be figuring out in pandas, there are many different notations of accomplishing the same thing. So as you're working together on the labs and homeworks, you might actually get different solutions for the same problem with the same answer. That's fine. Because in pandas, there are many ways of accomplishing the same feat. Lines 82, 83, and 84 are 3 different notations for giving me all rows where the state is not Texas. In the first one, UFO tilde, UFO state equals Texas. So it negates whatever's in the parentheses. In the parentheses, UFO.state equals Texas, it will negate that, so not equal to Texas. In the second one, line 83, it will, from UFO, select, square brackets, UFO.state equals Texas equals false. That's probably the longer, more convoluted way of doing it, but it still works. Line 84 is yet another way of doing it. UFO, select, UFO.state not equal to Texas, using the very basic not equal to notation from Python, the exclamation point equals, using the base Python not equals. So all of those are all legitimate ways of selecting all rows where the state is not Texas. Yes?
What's the tilde in regular Python?
Tilde in regular Python actually, I don't think, to my understanding, doesn't do anything. I believe tilde only has a meaning in pandas.
I think it's something like logical line or something, and it's not what you would expect.
Oh, I think it might be the XOR. I think it might be exclusive OR. If it is anything, it is a bitwise operation, which essentially means it does math at a very low level. Probably nothing that you've encountered in your pre-work. Definitely nothing you've encountered in your pre-work, and definitely nothing that we're going to be encountering in this class in base Python. But its meaning in Python and pandas are different. Its meaning in pandas is negating what's in the selection. Its meaning in Python, we believe, is a very low-level mathematical operation, which we will not be using. Line 86 will very similarly get all of the observations where the state is Texas, but instead of giving me the entire data frame, it will just give me the city column. So these are all the cities of the sightings in Texas. Burleson, Lago Vista, Houston, Austin, Fort Worth, Oklahoma, which I guess is a city in Texas. These are all the cities of the reportings in Texas. Line 87 is yet another way of doing the same thing. So again, we're seeing multiple ways of getting data frames and series in pandas. Which one should you do? That's up to you, honestly. In terms of computation, none of them are better than the other. It comes down to what you feel more comfortable typing out by muscle memory in the end. And as you do labs, as you do homework, as you do your project, you will subconsciously pick one and stick with it. But it is good to be aware of the other ways of accomplishing the same things if you want to help someone else out with their lab project, homework, whatever it is. Line 89, doing some more logic. Line 89 will choose from the data frame reportings in California or, note the bar, which is the Python OR operator, or Texas. So 14,929 rows are reporting in either California or Texas. Does anybody want to guess, tell me what line 90 will do? It is the same exact thing except for this one character. What does that one character mean? So what is it going to do? Show both California and Texas, which will be how many rows? We hope so. And you're right. There are 0 rows where the reporting was both in California and Texas. Note, it didn't give me an error, it just gave me an empty data frame. So even if the selection you're doing returns nothing, it will still give you a data frame, it will just be empty. So keep note of that. It won't throw an error because there are no rows in California and Texas. It will just return to you an empty data frame. So far, the new from Monday, we've learned the tilde operator up here. In fact, by new, I mean we've done this logic before. I'm just introducing a new character to perform the same logic. Down here, we've actually never done this before in pandas. We've never, explicitly on the board at least, we've never selected from a data frame using 2 or more logical criteria. And you can chain together as many criteria as you want. Texas, or California, or where the shape is light, or where the color is orange, or you can chain together as many of these as you want. Line 92 will create an object called UFO Dallas. UFO Dallas will be equal to, let's read this out, UFO Dallas will be, from UFO, select where the city equals Dallas and the state equals Texas. So what is UFO Dallas? What is UFO Dallas? Say it again? What is that command? What is the data frame that is going to be returned to me? Describe it to me. What is each row of UFO Dallas going to be? So UFO Dallas is the same 5 columns, but now every single row has Dallas, Texas. So these are all reportings from Dallas, Texas over time. Here's a new operator. And we've actually kind of hinted at it last time, or I think Liam mentioned the dot contains. I forget which one. Mentioned the contains. This is a similar method. It's called isIn. And it does exactly what you think it does. It will choose if the city is in Austin, Dallas, Houston. So in short, this line, bless you, 93, bless you, will give me a data frame where the city is either in Austin or Dallas or Houston. So there's a shorthand notation for chaining together 3 different ORs. And what we would get returned back to us is the data frame, but each city is either Austin, Houston, or Dallas. Any questions so far? I'm moving a little bit faster than Monday because as we do more and more data sets, the pandas will become the first step of many. So we, as data scientists, must be comfortable with this data exploration. We should be accustomed to doing head, tail, describe, filter these two columns, all right, sort, which we're about to get to. Sort by these two columns, do some value counts, plot, which we're also going to get to. This should become the first things that we think about. This will become the first thing you think about when you get in a data set, is let me describe it, let me value counts, let me plot, let me histogram, let me bar chart. So as we do more and more data sets, I will be casualier exploring the data set using panda. I'm sorry, that's not a word, but I couldn't think of the adverb for casually. I guess more casually. Sorting. So far, it's all been sorted by time. And that was fine. But now I want to sort by state. Here's a new method called order. Last time we saw sort index. Sort index generally is specifically for data frames to sort by the index, the 0, 1, 2, 3, 4, 5, unless otherwise stated. Order is a sort method specifically for series. So line 96 will just give me the states in order. As you can see, Arkansas is on top, and it gives me the first 30, second 30, Wyoming is on the bottom. So it just gives me the states in order, period. Line 97 sorts the entire data frame by the state column. So it will sort the state, but it will also include the rest of the data with it. So now, everything is not sorted by time, it's sorted by the state column at the right here. Sorted by state now.
So,
Yes?
when you do the line 96 with the UFO, the state or order, what was the point of that? Because I guess the other columns are not sorted, right?
Well, in this specific case, getting the orders of the state wasn't the most important thing for our analysis, but there will be times in your data set where one of your columns is, for example, time, and you just want to see what is the order of time that I'm looking at. If you have a million rows of tweets and they have a timestamp, sometimes you just want to grab the timestamp and just sort it by time and just to see the range.
Okay, so you're just manipulating on that.
Yes.
On that column.
Yes, and what you're hinting at is I'm not changing my data frame at all. And we'll get to that in a second. None of this is changing my data frame because I've never told it to, because there's a special keyword that we use when we want to actually change the data frame. And it's at the bottom, but we'll get there. We can sort by state. We can also sort by 2 columns, or 3, or 4, or all of them. We can pass into the by keyword a list of columns. And if we pass in a list of columns instead of a single column state, like in line 97, in line 98, I'm going to sort by state and shape reported. So it will sort by state first, and then within state, it will sort by shape reported. So if we scroll up now, we will see it has sorted by state. Once again, Arkansas is at the top. But now we look at shape. There's a cigar shape. I don't even know what that means. Then there's a circle, then various, and then you'll see the nulls. And the nulls are actually put last. They put the nulls last in order, which is generally a good thing. And we're going to deal with the nulls in a second. So we can sort by multiple columns. Not only can we sort by multiple columns, the ascending keyword, like last time, can also take in multiple accounts. So we can sort by state and shape reported, where the state is descending or not ascending, and the shape reported is ascending, least to greatest. So if I run line 99, the state will be descending, and I can check that by going up. The state is now descending, Wyoming, but the shape is still ascending, Chevron But cigar, circle. The shape is still ascending, but now the states are descending. So we can choose the order of sorting for multiple columns explicitly. Now, everything we've just done, sorting by multiple columns, ascending, descending, still doesn't change the data frame. None of that has changed the data frame. And how do we know? If I look at UFO, the times are still in order. That's our sanity check. If the times are in order, the data frame hasn't changed. So none of that changed the actual data frame. All it did was just show us a sorted data frame. All it did was just show us the value counts. The data was kept all intact. If I want to change something for real, I have to give it the in place equals true optional keyword. If I give it the optional argument in place, it will change the data frame. Not to show it to me, it will actually change it too. So if I sort by state, but now this time I've included in place equals true, nothing happened. However, when I look at UFO again, the times are now out of order, which leads me to believe, now the entire data frame is sorted by state. So the addition of in place changed the data frame. Everything else, nothing else has changed it so far. This is the first line of code that actually changed the data frame. So in place changes the data frame. If you don't put in place, it won't change the data frame. So here's a new feature. Duplicated. If we do UFO.duplicated, it will show. Yes, question. Nick.
Yeah, just a quick question. On the far left hand side, I think it's the index numbers.
Yes.
Those have changed as well, like those there is an associated column there.
Good question. So when we create the data frame, there is an index column that is implicitly also created. The index sticks with that row. So even when I sort, and maybe so here I'm going to sort by column 1. Column 1 is here. Maybe column 1 is here. Column 1 is C, B, A. Now my data frame looks like A, B, C, 2, 1, 0. The index moves with the row. The index is created at data frame creation and moves with the rows as we sort it. Mm-hmm.
So a follow-up question to that. So let's say I didn't have a date column, so it's much harder for me to reset my data frame. Can I reset it using that index, even though I don't see the index in the selectable column?
Good question. If you use sort index, it will implicitly, without giving it a by, sort index will implicitly sort it by the index. That's what it's called. Sort index with no parameters sorts it by this implicit column. If you give it a by, it will choose a different column to do it by. So whenever you're in doubt, you want to get back, well, I mean, the best thing you can do is just import your CSV. But if it's too big, you don't want to do that. You can just sort index with that argument, and it will reset it back to the index. Duplicated is similar to the is null, where it will look at each row, and it will show me if that row is duplicated elsewhere. Duplicated literally means that this row, in its entirety, every single column, exists somewhere else. Same city, same state, same time, same everything. Bless you. So line 111 will give me a list of trues and falses. This is very similar to the is null or the equals equals. It is applying to each row a function, and the output is true if it's duplicated, false if it's not duplicated, if it's a unique row. So now we have a list of how many trues and falses are in this list. Say it again? How many is that? You remember? About 80,543. The exact number of rows. For each row, it is giving me a true or a false. How could I know how many there are? Why does the sum work? That's weird. These are trues and falses. Because trues and falses, like we said on Monday, are actually zeros and ones, identically speaking. So if we add up all of them, there are 580 trues in that list, which means 580 rows exist somewhere else. Same time, same everything, same shape, same color, same state, same city. Now, does that mean, yes?
So if there's three duplicating records, so which one we label as true is what?
All of them, all three.
Really?
All three of them we will label as duplicated. So theoretically, one row could be duplicated 580 times, or 290 rows were each duplicated twice. Theoretically, either one of those could be true. But in this case, does that necessarily mean that those rows should be deleted? I hear no. Why not no?
One of them should be kept.
Why only one of them? Why not both?
Well, it would count for the frequency of people who had or viewed the same event.
It sounds like all of you are not believers. That's fine. But what if that thing did exist? Doesn't that mean multiple people would have reported the exact same thing? So aren't the duplicated rows actually more interesting to us? Because those are the actual different accounts of people reporting the same thing at the same time. That's weird. If this thing doesn't exist, there shouldn't be that many duplicated rows. Well, let's look at them. Here, we are looking at, excuse me, we are looking at the data frame where the state and time are duplicated. So these are all events where they were reported the exact same time in the same state. So all of these rows are repeated somewhere else in the same time and same state. Okay, that's interesting. Line 114 will show us all of the unique rows. So these are all the rows and only one person happened to see this thing in the sky, or one reporting was made about that thing in the sky. UFO unique is just putting a name to it. Now notice I've actually used two different terminologies. At line 114, I use the UFO.duplicated equals false, which means I want the non-duplicated. If duplicated is false, it's not duplicated, it's unique. Here, I just used the tilde notation. Negate UFO.duplicated. So this is the same exact operation using two different terminologies. Line 115 is just giving it a name. So UFO unique is now a data frame of only unique observations. And here we can look at the duplications by state and time, add those up, and there are 2,931 repeated events by state and time. So, again, I understand that UFOs might be a little sillier than some other data sets. However, the fact remains that when we look at null data or duplicated data, it matters the problem domain. The problem domain really matters. Because if we're looking at medical history of a single person, if the timestamp is repeated, that's probably bad. We shouldn't really have two different readings at the same exact time. That doesn't make sense. However, if we're dealing with UFO reportings, those duplicated data sets mean two people saw the same thing at the same time. That's interesting. So it really matters the problem domain, whether or not we're looking or care about duplicated or missing data. Yes?
Can you filter by
Oh,
seconds?
sorry.
It's Chris.
Yes.
Can you filter by seconds?
Say it again?
If I saw UFO and someone else in this room saw UFO but reported it, it would be a different time based on seconds.
Yes, but all the dates in this data set are to the nearest, usually 5 minutes. So you're right, it could be within like a 20-minute window. That could be the case. But they're assuming that if you saw this thing and you reported it, they ask you what time it happened. They're assuming it's around the same time. This is actually the data set that one of our former students used, and they actually did that. They actually said, if it's within a 20-minute window in the same city, it's probably the same reporting, and they got more duplications in that sense. But as it stands, the way it's reported, that's what the duplications mean. That's a good question. Yeah.
Is it possible to make stored view data? So like, is it possible to create a stored view of data? And so like, you have these views that are stored as separate data sets. If you were to go back and do something else with the data, it's only going to update whichever data set.
Like create a new CSV?
No, like.
I think she means like just calling, saving it as a new object, and then you keep on moving on, and you can look back and
Oh yeah, so every time I create a new object like UFO unique or UFO Dallas, I am making a stored view. Those are all separate objects in memory. So if I call a UFO, that's my original large data set. If I call a UFO unique, that is a separate data set that contains only the unique rows of UFO.
But is there any way to store a view that's a view of the original data set that's not its own separate data set? Like I think you can do it in like Oracle.
Oh, do you like save the environment?
Like
Kind of like open, close
Like
slider,
saving-
open it again, and it's the same thing.
like saving a filter almost. Like if you were to filter the data and name it like Dallas, if you were to go back to your original data set and change that data and filter it back by Dallas again, it's updated. I don't know if that makes sense.
It
Yeah.
does. Yeah.
So if you do Boolean indexing, it makes a copy. If you just select a column, you are actually creating a view of the column. You're not actually getting duplicate column.
So then my question is, can you save that view? So I don't want to copy the data set, I just want to reference that view again without doing the whole.
Yes, you can reference the view. But if anytime you use Boolean indexing, it is no longer a view because it's not a consecutive set of items. So you cannot say this new object refers these one first row, fifth row, 10th row. You cannot do that. So it needs to be consecutive objects in memory. Is this part of NumPy's architecture, which I think we get to
Okay. Thank you.
No problem. So moving right along, we can modify columns by adding new ones. Remember from last time, when we add columns together, unlike in base Python where we'll just concatenate the two lists together, how does the series addition work? What is it called? It happens element-wise. So when I add two columns, I'm really adding row by row the values in those columns. So when I say UFO city plus space, or space comma, plus state, and I call that location, the head, the first 5 rows, now include this new column called location. Location is a string where it says the city, comma, the state. So that's adding a column. Some of those columns, I don't like the name of them. Shape reported, color reported, I don't like the spaces. I don't like spaces in my column names personally, so I'm going to rename them. When I rename columns, I give it a dictionary where the key is the old column name and the value is the new column name. So notice the dictionary that I've thrown in here. Colors reported is a key, which is one of the old column names, colors reported, and the new name I'm going to give it is colors, just colors, one word. Shape reported is another key. Shape reported is another old column name right here, and the new value is shape. So when I run this and look at head again, now my column names have changed. Oop. Column names have changed. Colors and just shape. Makes it easier to work with, personally. We can drop a column temporarily. So this creates a view, not a new, it doesn't change the data frame. But if we drop location, it will give us 5 columns. Remember, we have 6 because of location is the new one. So with location, there are 6. And if I drop location, I'm back down to 5. What is this axis? Axis, it can either be 1 or 0. Axis equals 1 means drop the column. If I were to have said axis equals 0, what that would imply is I have a row labeled as an index, location, and I want you to drop it. But because I'm dealing with a column, I have to tell the drop axis equals 1. So whenever you're dropping a column, you must tell it axis equals 1. However, this is temporary. It doesn't happen to the data frame unless we tell it to. There's another shorter way to delete a column. If you remember the Python dictionary notation from pre-work, del was an operator to destroy one of the keys. Look familiar? It's exactly the same, because a data frame is pretty much the same as a dictionary. So I can treat it with similar dictionary notation. If I can select like a dictionary, why can't I delete like a dictionary? I can. When I del UFO location and I look at UFO, I'm back down to 5 columns. I added location and then I removed it immediately. Missing values. You've probably noticed that there are a lot of NaNs, not a numbers, just like last time. How do we deal with them? Well, how we deal with missing values generally depends on the problem domain that you're in, but we can at least use pandas to visualize how many there are and where they are. So .describe actually excludes missing data. If there's a data cell that's missing, none, not a number, null, it actually won't get included into the describe. Similarly, in value counts, notice at the top of value counts, light, triangle, circle, fireball. There's some cool, interesting teardrop. Teardrop. Value counts will exclude any missing data. Now, line 150 will do a value count with an optional argument. The optional argument drop NA equals false essentially says, hey, don't exclude the missing values. I want to see those too. When you do that, what you'll actually notice is missing is actually the second most reported shape. Light is the most reported, and then missing, a non-reporting of shape, is the second most common reporting of shape. So that's useful to know. Just like on Monday, the is null will put a true or false if it's not a number or missing or none. And if we add them all up, there are 8,402 missing shapes. I can call not null, which does the exact opposite. It will tell me if that row is not null. So true if it's good and false if it's bad. True if it's not null, false if it's not null. So this is where the Boolean can get a little bit confusing. And part of this is in the lab and homework, so you get some practice with it as well. So here are all of the rows where the shape is null. UFO select, UFO.shape is null. So there are 8,402, same number, rows where the shape is not there. Here's using some more logic, UFO, where the shape is not null, and the colors is not null. So what is this data frame going to tell me? Not necessarily the same, but you're on the right track. It will show me where the color exists, that actually was reported, and also the shape was reported. So this is all of the data. Only 15,516 rows of the 80, only 15,000 rows had both a shape and color reported. And here, just like before, I'm just saving it to a different object called UFO shape not null, where these are all the not null shapes. Now, how do we handle the missing values? Well, we can drop NA. So from the 80,543, if we drop NA, it will drop a row if any of the columns are missing. If any of them are missing, it will drop it. So there's only 15,000 rows where everything is there. We could also drop NA with an optional how with all. That will drop a row if and only if everything is missing. Anybody want to guess as to how many that will be? Why 0? So this will show me the data frame when I drop rows with everything missing. So if it's 0, that means every single row had everything missing. So I'm going to drop a row if all the columns are missing. So if this returns a data frame with 0 rows, that implies that it dropped everything.
0 rows will be dropped.
Why do you say that?
All of them have some time.
All of them have specifically a time and a state and a city. So the reason this dropped nothing was because all of them have at least one of the values in the row. And remember, without an in place, nothing changes. I've done nothing to the data frame. I've made new ones, I've sorted, I've replaced, I've filtered, I added a row and a column and deleted it. But right now, UFOs remain unchanged. Yes?
What are the values that you can put in how it was different?
There's any and all, and then I'll give it a list of columns. Yeah. Like before, we can fill. So I'm going to fill all of the NAs with unknown, with an in place. In fact, I can fill the entire data frame with unknown. Almost done with this data set. And then get to the fun stuff. See, it's labeled fun stuff, so you know it's fun. In case anyways. So, what will this line tell me? UFO, where UFO.shape equals triangle, dot shape 0. So what is this going to tell me? What is this? UFO.shape equals triangle. What is that going to show me? The data frame where the shape was reported triangle. So what does dot shape 0 tell me? Shape is the tuple. What's the first element? There are 7,816 reported triangles. Now I'm going to replace every instance of delta, which is, as we know, a triangle in Greek. We're going to replace delta with triangle, and I'm also going to replace pyramid with triangle. Notice I put an in place on both of the lines, which means it will actually change the data frame. So when I change the data frame and then run that same line of code, now how many have been added from before? 7, 8, 16, 7, 8, 24. 8. So there are 8 new ones. I replaced all the deltas with triangles and all the pyramids with triangles, and now there are 8 new elements called triangle. Here's some fun stuff that I want to run through really quick before Ramesh takes over for the election data. All right, so I've given you some code to make a month column. The month column will, as you guessed, will tell you what month it happened in. The day column will tell you what day it happened in. And the year column will tell you what year it happened in. So 1933, I think 2014 is the last year. I didn't do the 2015 data, sorry. So I have a month, a day, and a year column. So I'm going to plot the number of sightings per day in 2013. So in 2013, per day in order, in 2013, per day, this is how many UFO sightings there were. What do you notice? There seems to be a very large spike where? Around here. Looks like the 4th. Okay, let's investigate. Here, sightings per year, I'm going to group by year and then count by city. So if you actually look at that, per year, this is how many sightings were reported. So in 1930, there were 2 sightings. 1931, there was 2 sightings. As you can see, there appears to be more sightings nowadays than there were in 1930. Well, that's nice to look at the numbers, but it's even nicer to look at lines. What we're looking at is UFO reportings by year. There seems to be an explosion around what time? What year? Around 1993. Does anybody know what happened in 1993? Well, a lot. The internet existed. More importantly, 1993 is the year the X-Files came out. Fun fact, not saying that has anything to do with this, but the aliens clearly love the X-Files. And that is their target demographic. So around the time the X-Files started appearing on the air, there seemed to be a lot more UFO reportings. Okay, well hold on, Sanan. Let's not jump to conclusions. That's not what we are all about. Maybe, well hey, there was a population increase, right? There's a population increase in that time. So maybe the population also boomed around that time. Well, I've taken the liberty of going to the US Census and taking population data. And here it is plotted from 1930. Seems to be a pretty steady increase of population. No really big boom around 1993. So I'm going to go ahead and chalk it up to probably not due to the fact of population increase, because there seems to be an exponential growth of UFO sightings, where there seems to be a very steady growth of population. Now, let's plot the sightings on July 2014. So we're going to, from the UFO, thank you, where the year is 2014 and the month is 7, July, we're going to group by day. So of the sightings in July 2014, we're going to group by day and then plot them. There seems to be a very large number of reportings on July 4th, 2014 as opposed to every other day. But hold on. Let's not jump to conclusions. Maybe that's an anomaly in 2014. Well, I went ahead and did it by the last 4 years. 2014, 13, 12, and 2011. If you just plot it in one plot, what you will get is this stacked bar chart where they're all next to each other. I've also taken the liberty of splitting it out into 4 different charts. So, what we're looking at is the number of UFO reportings in the last 4 Julys. Now, in the last 4 years, 2011, 12, 13, and 14, all of them seem to have a very large increase of UFO reportings on July 4th, which leads us to believe one thing and one thing only. Independence Day is real and it's going to happen. So somebody call Will Smith, not Jaden. Jaden can stay home. Willow can come. She's fine. That's their son and daughter. Okay. Last thing before I turn it over to Ramesh. There is one very simple method called 2CSV. 2CSV does exactly what you think it will. It will take all the changes to UFO and make a CSV of it. What is it called? Whatever you put in this parameter. So in this line, we're going to make a UFO new CSV. If we turn to our Explorer, you see UFO new CSV is now a new file. Very simple to turn a data frame back into a CSV when you're done and you want to export it to somebody else. Okay. In the last hour, we have gone through, extensively, to a UFO data set using pandas exploration tools. Now, we're going to switch gears to doing more pandas with a different data set. Ramesh, would you like to show us? So what we're going to be looking at, do you want to use my laptop or are you going to bring your own?
Yeah, anyway, yeah, I'm grateful.
Go for it. Did you do that? Do you want to use my laptop or yours? Okay, why don't you use your laptop? You're probably more comfortable with it. Work.